Okay, so ionic bonds is formed from transferring electrons. So do you remember sodium? Sodium is 281, right now. Okay, so in order to achieve full outer shell, what will sodium do? Try and get rid of that one electron, right? Okay, now when sodium gets rid of electron, you must have somebody to receive. You cannot just say, you go, you give away. Somebody must be able to take the electron. So the one that takes the electron has to be a non-metal. So for example, let's say chlorine. Chlorine is 287. How many more electrons does it need? One. So this one will go there, it will receive. So from 287 is 288. Now this one becomes chloride and this one becomes sodium positive. Can you understand? Okay, so this is what happens. The ions are atoms or group of atoms that lost or gain electron. The atom losing the electron will form a positive ion or a cation, and it has to be a metal. The overall charge changes. Okay, the atom gaining the electron becomes a negative ion or an anion, and it's always the non-metal. So, okay, can now everybody in group one because it has one valence electron, so it always release one, so it become one positive. Everyone in group two, positive two, everyone in group three, positive three, everyone in group four, team doesn't react, it only does covalent. Okay, and then group 15 receive 3, 3 negative. Group 16 receive 2, 2 negative. Group 17 receive 1, 1 negative. Okay, then 18 doesn't react because it's called group 0 or group 18 because it's full outer shell already. Can you understand? Get it, someone? Yeah. Now, lithium is group 1. It has one electron. So if I write like this is lithium atom 2, 1 becoming 2. And then one electron release. This kind of equation is called a half equation. Can you write this down? Can you write this down? Okay. Now, if it's magnesium, how do you write the half equation? Can you try? Try and write the half equation. Magnesium from 282 becomes 28. Write down the half equation for magnesium. Because Mg2 plus 2A. Did you get it correct? Plus 2A. Okay? Okay. So from 282 it becomes 28. So this is called a dot and cross diagram. Now, fluorine is different. Fluorine has 7 valence electrons. How many does it receive? One. So, if you notice here, from 7 it becomes 1, right? Okay, I want you to make a change to it. One of it, draw X. Because this is to show the last electron is from a metal. It's from somebody else. Okay, how do you write half equation for this? Fluorine receives 1 electron to become fluoride, right? Okay, however, fluorine exists as a single atom or a diatomic molecule. Group 7 is 1 1 1 1 1 or 2 2 2 2 2. Hello? No. Fluorine, chlorine, bromine, iodine. You forget already the list. Fluorine, chlorine, bromine, iodine, hydrogen, oxygen, nitrogen, all acts as double, right? So it's F2 plus 2E become 2F negative. Okay, get it? Okay, please do the same thing for oxygen. Okay, so one oxygen, this one, right? Look at this, six of it belong to original, the other two is seven, eight. It's from somebody else. Get it? Oxygen receives two electrons to become O2 negative. But oxygen exists as O2, four electrons. That's okay. So this is how it looks like. This is how the half equation looks. Okay. All right. When metals react with non-metals, electrons are transferred from the metal to the non-metal, forming ions. Each of these, when there is a positive and negative ions, the ions will be attracted to each other, and that forms a electrostatic forces of attraction. So after it's formed positive and negative, okay, so it's basically like this. I start with sodium, you start with chlorine. I give you one, you take one. I become positive, you become negative. Then you thought, oh, now we're all happy, bye-bye. But cannot. Why? Because they cannot leave each other because they're attracted by electrostatic forces of attraction. Okay, can? All right, let's try this. So sodium is 281. Chlorine is 287. Okay, half equation. Half equation. Chloride. Negative is negative ions got IDE. Okay, this is half equation. What is ionic equation? The positive ion and the negative ion get together to form sodium chloride. This is ionic. Okay, okay. Chemical equation. Chemical equation is like this. You start out with sodium and you start out with chlorine. What is your end product? Start with sodium and start with chlorine. What's your end product? Sodium chloride. Can you please balance this equation? So this is called chemical equation. So you balance it 2, 2. Can you understand? So there's chemical equation, half equation, ionic equation. All right. This is called a dot and cross diagram. So if you notice here, 2, 8 is on the electrons are in the form of dots, right? When one of it come over here, you can see this is a dot. 287 is the original one from chlorine. The dot is from sodium. Okay? Okay. Okay, usually the nucleus, right? We don't need to draw. Usually they will leave it like this. And then what you do is you write down an A in the middle and then Cl in it. Okay? Okay? This, you draw a bracket, positive, draw a bracket, negative, and this is our sodium chloride ion. The dot and cross diagram looks like. Can you understand? Can. The most important thing for you to see is this one. This one came from here. Okay, got it. Right. Okay, try and do this. Come on, you guys. I know, very tiring. Eyes very tired. Today's Monday is the Okay, ready? Okay, so magnesium, 2,8, 2, oxygen, 2, 6. Half equation, Mg become Mg2 plus 2E. Half equation, O2 plus 4 electron become 2O2 negative, right? Ionic equation, Mg2 plus O2 negative become MgO. Chemical equation, Mg plus O2 become MgO, put a 2 here, put a 2 here. Did you get this correct? Yeah? Yep. So, okay, so this is how magnesium oxide looks like when you draw a dot and cross. Will you be able to draw this in exam? Will you be able to draw this in exam? Yes, of course. Okay, can you understand so far? Okay. Now, if magnesium oxide is like this, calcium chloride, okay, how many chlorines you need to react with the calcium? Calcium is 2,882. It releases 2. Chlorine is 287. It only needs 1. So one calcium go to one chlorine. Another calcium goes, sorry, the same calcium goes to another chlorine. So you will have 2 chlorine, 1 calcium. So it becomes CaCl2. Get it? Do you understand why? Calcium want to release how many? 2. Chlorine each can receive how many? 1. So I give you 1, I give the other one to this fella lah. One go here, one go here lah. Oh, what's that not to understand? I think you exam 你的头脑烧了. Okay, so in this case, calcium chloride, the formula would be, okay, write down the equations for all 3 equations. Half equation, ionic equation, chemical equation. Go, write it down now. Half equation, ionic equation, and chemical equation. Okay? Okay, half equation, calcium becomes Ca2 plus 2E. Chlorine receive 2 electron, become 2Cl negative. Ca2 plus 2Cl negative becomes CaCl2. Calcium plus chlorine becomes CaCl2. This is half equation. This is ionic. This is chemical. Okay. The paper is there empty space at the back? Not like the last page is empty. Empty-ish lah. Okay, I want you to draw something. Okay, this is what I want you to do. Okay, I want you to write out the half equation and then ionic equation and then the overall chemical equation and also the dot and cross to make lithium nitride. Okay, try. Look at periodic table. Okay, so first you need to do is lithium. Did you get this correct? Okay. Nitrogen is 2,5 ma. How many does it need? How many does it need to achieve full outer shell? Three lor. Nitrite ion. But then nitrogen must be two. So this one, six. Get it? Okay. So ionic equation. So what is the formula? Li, 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 three, and do you remember why? Yeah. Chemical equation from 2, 1 become 2. So I need three of this, right? Okay, usually we draw three, but I'm going to give you a shortcut for this time. We draw three. How to draw next time in the exam? Ask your teacher. I would say just put a three in front, but some of your teacher wants you to draw all three. Okay, two. Okay, this is how to do. Okay, can you look? Give us a one, two, three, four, five, six, seven, eight. Get it? Ah, must be paired. Okay. Okay. Get it? Do you understand now? Draw already? Okay. If you not enough space, you take another piece of paper. Draw. Alright, we're gonna do one more. So we did sodium chloride when it's outside. Okay, I wanna do aluminium oxide. Okay, do everything based for aluminium oxide. Get it? Hmm. Okay, go do. Okay, ready? So now Aluminium is 283, right? So it becomes 283 positive, right? Oxide, 2 6, right? Okay, how many aluminium and how many oxygen? Okay, it's Al2O3. So here 3, 2. Correct? Did you balance this? The ionic equation? 2 and 3? Okay. So it's 2 aluminium, 3 oxygen. Okay, do you get this correct? Okay. Do you understand the concept now? Yes? Okay. Okay, they don't exist as just one atom like that. No. What happens is when the reaction happens between the positive and negative, there is electrostatic forces of attraction, right? Here. But you must understand it doesn't just stop there. Next to every positive is a negative. Next to every negative is a positive. And it goes on and on and on and on. That's why you have salt crystals here at the back also got. It's a 3D structure that goes on and on and on. Not just here, it goes on and then on and on and on. Okay. So basically, next to every negative is a positive, best next to every positive negative, and on, and this way, and this way, and this way, all go on and on. Can you imagine? So it's called a giant lattice. Okay, it's called a giant lattice. And what happens is every single positive and negative ion are held together by strong what? What is the name of the bonds that hold positive and negative? Strong. Hello, I learned to you just now. Between positive and negative is called what? E. You learn this in your just now that one, the periodic tables you learned. What is it called? E? Yes, correct. Electrostatic. Okay, so it's strong electrostatic forces of attraction. Forces of attraction. So it's between all the ions. So because of this, do you think this compound will have high melting point or low melting point? There are many, 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 many strong electrostatic forces of attraction. High melting point or low melting point? High melting point. Okay, number one is high melting point. Number two, it is soluble in water. Okay, number three, do you think it can conduct electricity? In order to conduct electricity, there must be something to carry the electricity. There are only two things that can carry electricity: electrons and ions can carry electricity. So it's like a car, electrons is like a car, ion is like a lorry. Okay, they can carry electricity. Electricity is basically what a passenger lah. Okay, can carry electricity. However, if the electrons and ions are not moving, does it carry? If your car is not moving, can it bring you anywhere? No, right? Okay, so the key word here is it has to be freely moving. Okay, it has to be free moving electrons or ions. All right, can? Now, when it's in a solid state, right? The ions are not freely moving. So like pure salt can conduct electricity or not? Cannot. Okay, but then what you do is you can melt the salt. Melting it is called molten, or you can dissolve in water. Dissolving in water is called aqueous. Can you understand? Okay, so if you look at your notes here, these are all called the properties of ionic compounds. Okay, salts and metal oxides are typical ionic compounds. These structures are brittle. Do you know what's brittle? Brittle means like, you take a piece of salt, you can crush it. That's brittle. Okay. It is hard but brittle. High melting point and boiling point. Okay. They are crystalline solids at room temperature. In room temperature, salt is a solid salt. They are hard but brittle. They are not malleable, but they are soluble in water. Okay. They can dissolve in water because ions can separate. All right. The solid crystals do not conduct electricity, but if they are melted or dissolved in water, melted is called molten, dissolved in water is called aqueous. The ions are now freely moving and can conduct electricity. Can? Okay, I will stop here before your brain explodes. Okay, what does the ionic bond involve? ABC, I'm gonna kill you. Think again. B lah. How to share? They're not sharing. I give you, you take. How is it share? Joe. No, sharing is covalent. Literally, I told you the positive say, I give you. I give you. Yeah. Where do electrons lost by metal atoms go? Where do electrons lost by metal atoms during the formation of ions come from? The outermost shell. Must be the outermost shell, okay? Which statement below is correct? Metal atoms form negative ions. No, metal atoms form positive ions and non-metal atoms form negative ions. Yes, B. Okay? An element with a group forms a charge with positive. Which group is most likely to be in group 2? What is an ionic bond? Forces attraction between oppositely charged ions. Oppositely charged means positive and negative. Okay, the electronic structure of aluminium is 283. What's the electronic structure of aluminium ion? 283 positive. Can? Do you understand now? Okay, so it has to be metal and non-metal. Okay, I'm going to give you names. You're going to tell me the formula. Okay, and whether it's ionic and covalent. I want you to do one more of just now that one, right? I want to do one more. Just now that one, right? I'm going to do one more because you all are like in la la land like that. Okay, can we do one more? Can you please find some paper? I don't have enough. I don't have any space. You still have? Okay, very good. Okay, so we did aluminium oxide. We did lithium nitride. Let's do one more. Let me think. Mm, okay. Uh, Magnesium phosphide. Okay, do the same thing. You done? Okay? It looks so sad. All right. So magnesium, what's the electron arrangement? 282 becomes 28. Right. That is so many times already. Phosphorus is what? 285. Okay? So Mg3P2. Right? Okay, how to balance? 2, 3, 2. Okay, now sometimes they will write phosphorus as P4 because in reality, a molecule of phosphorus exists as P4. But if they don't write for you, you can just ignore. You can usually just use P. It's the same as sulfur. Sulfur actually exists as S8, but they usually don't write for exam. Okay, can. So how will this look like? So Mg, then phosphorus. 285. 1, 2, 3, 4, 5, 6, 7, 8, 3 negative. Okay, do you all get it now? Get it? Yeah. So it has to be metal and non-metal. Okay, it has to be metal and non-metal. So basically, it is only between group one, group two, group three, who become positive one, positive two, positive three, and group 5, 15, sorry, 13, 16, 17, who become negative 3, negative 2, negative 1. So it just mix and match between these. And this whole group is what? A metal. Okay, and what happens to the electron? Share or transfer? Driven? This is a metal transfer to the non-metal. Okay, can? All right. Now we go to the next one. Covalent. Okay, this one you must remember. This one they love to ask. Now it's covalent. Covalent is sharing a pair. Now finally can share. Okay, it's only between non-metals. Only non-metals and non-metals. Okay, so it's like this. For example, hydrogen has one. How many more does it need to achieve full outer shell? Mm. So hydrogen talks to another hydrogen. Please, 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 can you give me? No, 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 you give me. No, you give me. No, you give me. Then they fight, 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 fight. Then suddenly, so this hydrogen thinks it has two, this hydrogen thinks it has two. Is everybody happy? Yes. So this is called a single covalent bond. Can you draw this? Okay. Now, one line, one line represents how many electrons are shared? A pair. One line represents two electrons shared. Okay? Okay? One line is two electrons shared. Okay, you can draw like this in the middle. Sometimes your teacher will say it's okay to draw like this, share. But like this is absolutely wrong. If you draw like this, it's absolutely wrong. Okay, now I would recommend you draw like this. This is better because can see clearer. This one okay, but not that, not not so advisable. Okay, okay. So how many bonds? So remember we have group 14, group 15, group 16, group 17. Okay. And then we also have hydrogen. Hydrogen only forms one bond. Chlorine, group 7, everybody in group 17 forms one bond. Everybody in group 16 forms two bonds. Group 15 always three bonds. Carbon, group 14 always four bonds. Okay? Can? All right. So this is what I put for you this now. This is called dot and cross. This is called a Lewis structure. That means this one has one valence electron, this one has one valence electron. We share like this. Okay? Can you get it? Okay. Now, fluorine, wait, fluorine has seven electrons, seven valence electrons. So fluorine is 2, 7, right? How do you think a molecule of fluorine will look like? How many bonds will it have? Hello, one bond. Very good. So this fluorine and this fluorine, okay, like this. This fluorine, two, the inside two I don't want to draw lah. I just draw the outside seven. Okay. One, two, three, four, five, six, seven is for sharing. One, two, three, four, five, six, seven. One is for sharing. Is this still a single covalent bond? Yes. So it looks like this. Can you understand? Please draw this. Please draw this and do example 3. Is your soul caught up with your body? I know, I know, like, really? Green? On it. Sure. All right. You have your water. Do you guys have class after this? Okay, I'm not going to draw the inside for chlorine. 2, 8, I already zero. So 1, 2, 3, 4, 5, 6, 7. Do you get it correct? Okay. All right. Can you try 4, 5? 4, 5. Try 4 and 5. All right. So this one, carbon 2, 4. Hydrogen is 1. So this one forms 4 bonds. Hydrogen 1 bond. Okay, so this one will also look like this. This is called a structured formula. So this one will look like this. Okay, so I'm not going to draw the inside one. I'm only going to draw the outer shell because I have no space to go. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Do you get it correct? So this formula is CH4. This is called methane. Methane is your cooking gas lah, in your gas stove at home. Can you understand? So this one is called dot and cross. That one is called a display or a structural formula. Structural or displayed formula. This one is called dot and cross. Okay, okay. This is names lah. So this is covalent. Do you know why? Do they transfer or share? This one is share. Okay, this one is share. So it has to be non-metal and non-metal. Understand? Okay, ammonia is nitrogen, which is 2,5. So nitrogen has 3 bonds. Hydrogen is 1 bond. Okay, so it looks like this. And H. Okay. This one, what students always forget is when you draw this, right, you must remember it is 2, 5, right? So 1, 2, 3. Don't forget here. Got a pair of electrons here. 4, 5. Okay. Okay. Okay, this one is single covalent. So this one is 3 single covalent. Okay, now I'm going to show you double bond. Double bond is when two pairs are shared. So oxygen, right, is 2, 6. So they have to have 2 bonds. So oxygen molecule O2 is like this. It is double bond. Okay, how to draw the double bond? Okay, draw nicer for you. Do you want to try? 2 pairs are shared. 2 pairs are shared. So 1, 2, 3, 4, and here you go 5, 6. 1, 2, 3, 4, 5, 6. Done, done. This. I'm just showing you it has to be 4, 4. There are 2, 2, sorry, 2, 2 and 4 sides. Can you understand? So here is 2 pairs of electron shared. So it's called a double covalent bond. So it's 4 electrons, 2 pairs. So this thing here is this thing here. Get it? Okay. You do one last one, then you can go. Can you try to draw carbon dioxide? Okay. Done? To carbon, to four, oxygen to six. So carbon dioxide will like this. Carbon is four bonds. Okay. Try and draw, try and draw. Okay, ready? One, two, three, four. One, two, three, four, five, six. One, two, three, four, five, six. All right. Did you notice? Okay. So what I want you to go home and do is try and finish it. Try and finish all the bonds. Two more. Triple bond, you figure it out lah. The same thing, and then finish all the questions. Can? Can. Okay.